welcome back to Hop into Precalculus. Today we're covering two really important topics, simplifying polynomial and rational expressions and the transformation of functions. By the end of this, you'll be able to clean up messy algebra and predict how a graph will look like. Okay, so these are the topics we will be talking about today. 1.11, equivalent representations of polynomial and rational expressions, and 1.12, transformations of functions. This is factored form, and this is the factored form of a polynomial, and this is the factored form of a rational function. And then it is easy to find x-intercepts, asymptotes, holes, and domain in factored form. For example, here you can find that some of the x-intercepts are -1, 4, and 2. And then for asymptotes here, you can find that the asymptotes are x equals 1, -3. Holes, you can cancel these out to find the hole. And then domain, you can see just whatever makes the denominator a 0 will be not part of the domain. Okay, now we have standard form, and this is the standard form of a polynomial, and this is the standard form of a rational function. So from here, it's easier to find n behavior and y-intercepts. For n behavior, you just look at the type of function. Here, it is a odd-degree polynomial with a positive leading coefficient. And then here, they have the same degree, so it's just 1/2. And it's also easy to find y-intercepts because you can just plug in x equals 0 and get the x-intercept is 6 here and then 5/3 here. Something that's new is polynomial long division. So first you write it here, and you write this, x plus 1. So first you see how many x plus 1s will fit into x squared. So if you multiply x, then you will get x squared plus x. And then you have to subtract that from here. So then you'll end up with 5. And then there is nothing that can be multiplied to x plus 1 to get 5. So then we write our result with the remainder over our divisor. So our answer is a binomial expansion is when you have a binomial to a power. And then the easy way to expand it is to use Pascal's triangle, which is this. And then also, so if it's to the third power, then you use the row that has the 3 after the 1. So that means you have the coefficients 1, 3, 3, and 1. So for the first one, just do 1 times the first one cubed, and the second one to the 0 power. After that, you have this one, this coefficient, and then x squared, and then 1 to the first power. Then you have 3x1 squared, and then finally you have 1x to the 0, 1 cubed. So that means you end up with x cubed plus 3x squared plus 3x plus 1 as your result. In these graphs, the black colored function is the parent function, and the purple one is the transformed one. So first, if you add a constant to the outside, it's a vertical translation, so it could go down or up. If k is negative, then it will be shifted down, and if k is positive, then it will be shifted up. For this one here, it is a horizontal translation, and it's when you add a constant in the inside. So this one is a bit more weird because if h is negative, it'll actually go to the right side, and if h is positive, it'll go to the left side. Before we talked about rigid transformations, which means the shape of the graph didn't change, but now these are dilations, which actually change how the graph looks. So first is a vertical dilation, and then in this example, a equals 3, and then it gets skinnier and skinnier when you use a bigger a. For this one, it's a horizontal dilation, and it means like getting flatter and flatter. And that happens when you multiply a b inside of the x. Time for a practice problem. So this is polynomial division, and then we're going to write it. Okay, so to get from x squared to x cubed, you need to multiply x. So then you write x here, and you subtract. And then after that, you get and then you can multiply x squared minus 2x plus 1 by 4, and then you can get rid of those. And then you end up with 3x minus 1 as your remainder. So your answer will be Let's do a binomial expansion one again. So let's first draw the Pascal's triangle. And then we use this later because the second number is the number that our binomial is raised to. So we have the coefficients. First we do 2x cubed and 1 to the 0 power. Then is 2x squared and 1 to the first power. Then it's 2x to the first power times 1 to the second power, and then 2x to the 0 power times 1 to the third power. So it will be 8x cubed plus 12x squared plus 6x plus 1. Great work today. You learned how to use different formats of rational and polynomial functions and how to apply transformations like shifting and stretching. These are skills that you'll use in pre-calculus and beyond. If this video helped you, make sure to like, subscribe, and leave a comment. Thanks for watching, and I'll see you in the next video.